Hello students, welcome to my channel. In this class, I am going to teach you continuous function. I shall give you the definition of a continuity and also solve some problems on continuity. Let us start the topic. First, definition of a continuity. A function f of x is said to be continuous at x is equal to a if it is satisfied the following conditions. The first condition is f is defined at a. What does it mean? It means a is the domain of the function. Means here f of x is given to us. In place of x we put a. We have to find f of a, and that must be defined. The second one is limit extending to a f of x exists. It means we have to find the left limit of the function at x is equal to a, and also the right limit of the function at x is equal to a. The right limit of the function must be equal to the left limit of the function. The third condition is the limiting value must be equal to the functional value of the function. So by which we can say function is continuous at x is equal to a. So let us solve a problem basing on this definition. Examine the continuity of fx is equal to 2x plus 1 when x less than 2 and fx is equal to 3x minus 1 when x greater than or equal to 2 at x is equal to 2. So we have to test the continuity. In order to test the function is continuous, so let us verify the following condition. In order to test the continuity of fx at x is equal to 2, let us verify the following conditions. So first of all, here fx is equal to 3x minus 1 at x is equal to 2. Because fx is equal to 2x plus 1 when x less than 2. Fx is equal to 3x minus 1 when x greater than 2. And fx is equal to 3x minus 1 when x is equal to 2. So fx is equal to 3x minus 1 and x is equal to 2. Implies f of 2 is equal to 3 into 2 minus 1. So f of 2 is equal to 3 into 2 minus 1 is equal to 5. So f of x is defined at x is equal to 2. Now let us proceed to verify the second condition. So we have to find the left hand limit, then right hand limit. Left hand limit of the function is equal to limit extending to 2 minus fx. Here 2 minus means x less than 2, fx is equal to 2x plus 1. So when limit extending to 2 minus, it means the value of x is slightly less than 2. So in that case, our functional value is 2x plus 1. So we can write this is limit extending to 2 minus 2x plus 1. So this is equal to limit h tending to 0, 2 into 2 minus h plus 1. So this is equal to 2 into 2 minus 0 plus 1, which is equal to 4 plus 1 is equal to 5. So the left hand limit we are getting, and this is equals to 5. Then right hand limit is equal to limit extending to 2 plus f of x. So it means the value of x is greater than 2. So here fx is 3x minus 1. So this is equal to limit h tending to 0, 3 into 2 plus h minus 1. So this is equals to 3 into 2 plus 0 minus 1. And this is equal to 6 minus 1, which is equals to 5. So left hand limit is equal to right hand limit is equal to 5. That is limit extending to 2 f of x is equal to 5. So the second condition is verified and we are getting limit extends to 2 f of x is equal to 5. Now let us proceed to verify the third condition of continuity. Here limit extending to 2 if x is equal to 5 and the functional value in the first step, that is f of 2 is equal to 5. So we get limit extending to 2 f of x is equal to 5 is equal to 2. Hence the given function is continuous at x is equal to 2. So our first problem is now solved. Let us proceed to solve the next problem. Okay, our next problem is find the value of a if the function fx is given by fx is equal to 2x minus 1 when x less than 2 is equal to a when x is equal to 2 equals to x plus 1 when x greater than 2 is continuous at a x is equal to 2. Solution. Here f of x is equal to a at x is equal to 2 implies f of 2 is equal to a. Now left hand limit is equal to limit extending to 2 minus fx is equal to limit extends to 2 minus means x less than 2 fx is equal to 2x minus 1. So this is limit h tending to 0 2 into 2 minus h minus 1. So this is equal to 2 into 2 minus 0 minus 1. This is 4 minus 1 is equal to 3. Now right hand limit of the function limit extending to 2 plus fx when x tends to 2 plus, then fx is equal to x plus 1. So limit x tends to 2 plus x plus 1. So this is equals to limit age tending to 0, 2 plus age plus 1. So this is equal to 2 plus 0 plus 1 is equal to 3. So left hand limit is equal to right hand limit is equal to 3. That is limit extending to 2 f of x is equal to 3. But it is given that the function is continuous at x is equal to 2. Given f of x is continuous at x is equal to 2. This implies limit extending to 2fx is equal to 3 is equal to the functional value f of 2 which is equal to a. So this implies a is equal to 3. So our second problem is now solved. Let us proceed to solve the third problem. Our third problem is examine the continuity of fx equal to x plus 1 if x less than 0 is equal to x if 0 less than x less than 1, 2x minus 1 if x greater than or equal to 1 at 0 and 1. Solution. First, to test the continuity at x is equal to 0. Here f of 0 is not defined. So here f of 0 is not defined. Hence fx is not continuous at x is equal to 0. To test the continuity at x is equal to 1. Here f of x is equal to 2x minus 1 at x is equal to 1. So here fx is equal to 2x minus 1 if x greater than 1 is equal to 1. So fx is equal to 2x minus 1. This implies f of 1 is equal to 2 into 1 minus 1 is equal to 1. So fx is defined at x is equal to 1. Fx is defined at x is equal to 1. Now left hand limit extending to 1 minus fx. This is equal to limit x tends to 1 minus. So when x less than 1, fx is equal to x. So this is limit age tending to 0. So this is 1 minus 0 is equal to 1. Now right hand limit extending to 1 plus f of x is equal to limit extending to 1 plus. 1 plus means x greater than 1. Fx is 2x minus 1. So this is limit age tends to 0 to 1 plus x minus 1. So this is equal to 2 into 1 plus 0 minus 1. 2 minus 1 is equal to 1. So left hand limit is equal to right hand limit is equal to 1. This implies limit extending to 1 f of x is equal to 1. So the second condition is also verified. The third condition, here limit extending to 1 f of x is equal to 1, which is equal to f of 1. So the limiting value equals to the functional value. Hence, the given function is continuous at x is equal to 1. So, here in this question, we find the function is discontinuous at x is equal to 0, but it is continuous at x is equal to 1. The first condition is satisfied here. Fx is given, f of 1 is 1, so it is defined at x is equal to 1. The second condition, we are getting left and right limit both are same, limit exists. And the third condition, limiting value is equal to functional value, hence the given function is continuous at x is equal to 1. So with this, our third problem is solved. I shall meet you with a new topic in my next class. Till then, goodbye.